Our next topic is, what if the recurrence relation is not homogeneous? The recurrence relation is non-homogeneous if on one side of the equal sign all the terms have AIs, and on the right hand side we have a function that is not equal to 0. If this function is equal to 0, then we say it is homogeneous. If it is not equal to 0, then non-homogeneous. This function may consist of more than one part added together. So we will consider some of a special functions that we can find roots, or we can find a solution by using the characteristic polynomial. As an example, so if we have an example, and we have covered this before, if we have a recurrence relation that is equal to 3an minus 1, let's say plus 7. Now when you rewrite the recurrence relation, when you rewrite it, then it will be an minus 3an minus 1 is equal to 7. So this is the function I'm talking about, f of n. And although we don't have n, because we assume that this function is equal to 7n raised to power 0. So it's a polynomial of degree 0. So it's a constant, but if you convert it into polynomial, then it will be equal to 7n raised to power 0. Now, such recurrence relations will be divided into two parts. We will have the first part, which is the homogeneous part, and the other one is the non-homogeneous part. Later we will call it particular solution. Okay. So later we will find a particular solution for this part. Okay, solution, we will need to write it clearly. Solution. So to find the characteristic polynomial, first we need to find the characteristic polynomial for the homogeneous part and for the non-homogeneous part. For the homogeneous part, this is a recurrence relation of degree 1, so it will be x minus 3. And for the non-homogeneous part, we need to find a root for 7. And we need to know what is this root. And also look at the characteristic polynomial. We have roots for the homogeneous and we have roots for f of n. The roots you find, maybe 1, maybe 2, maybe 3, you find for f of n should be multiplied by the roots of the homogeneous. So you don't add them, you multiply them here. What type of functions that we are going to cover? The type of functions that we are going to cover should be in this form. So it's an exponential multiplied by a polynomial. We can categorize those functions into the following. Maybe it's a constant, and as an example, if f of n is equal to 3 or 4, like our previous example here, which is equal to 7. Or it can be only exponential. So if only exponential, as an example, f of n is equal to 4 multiplied by, let's say, 7 raised to power n. So this is exponential. Or it can be only polynomial. And this polynomial could consist of one term or more than one term. So it could be n squared, which is one term, or plus 7, which is two terms, and etc. And the last one is exponential. Multiplied by polynomial. And an example of this, f of n is equal to 3 multiplied by 4 raised to power n multiplied by n squared, or multiplied by n squared plus 1. We will go over them one by one and show you what will be the root, okay, if it is a constant. So if it is a constant, what will be the root? If it is only exponential, what is the root? If it is only polynomial, what is the root? And if it is exponential multiplied by a polynomial, what is the root? We are going to cover only those types of functions. Any other functions, then we must find different way to find a solution. And homogeneous recurrence relations. We need to have on the other side a summation of terms of this format. It should be b raised to power n multiplied by a polynomial equation. We will go for them one by one. Any equation that applies or confirm to this equation, then we can find the root directly for this equation. So if we have it in this form, then the root will be equal to x minus b raised to power d plus 1. And if we assume that this one, the polynomial, has degree d. So any formula you have on the right hand side, f of n, of the recurrence relation is of in this form, b as a constant raised to power n and multiplied by a polynomial, then the root will be simply x minus b raised to power, it depends on the degree of this polynomial. We will go for some examples. So examples. Suppose we have f of n is equal to a constant, let's say 3. Now how can I write a 3? Okay, so how can I write a 3 as a number raised to power n multiplied by a polynomial? Simply we can write it as follows. We can write this equation equal to 1 raised to power n multiplied by 3n raised to power 0. If you, any number, 1 raised to any number is 1. So this is equal to 1. And n raised to power 0 or any number raised to power 0 is also equal to 1. So what is the value of b in this equation? This is the value of b. And this is the value of the polynomial, which is p of n. So I can write them separately, that p of n is equal to 3n to the power 0, and this is degree 0. So what will be the root? So the root is, you open a bracket, it will be x minus b raised to power d plus 1. So b is 1, so it will be x minus 1, and d is the degree 0. So here I should write that degree is 0, so d is equal to 0. Then this root will be raised to power 1, so the root for 3 is x minus 1. And notice that if you put instead of a 3, you put 4, you will get the same answer. If you put 5, you will get the same answer, because the polynomial that you are going to get, they differ only by the constant here. And all will end up that the degree is equal to 0. So in other words, if we have a constant, then the root is x minus 1, and this is the first equation, or this is the first root, okay, for a constant, as if it is included in the homogeneous recurrence relation. For another example, if this is 1, now what if I have f of n is equal to, let's say, 4 multiplied by 3 raised to power n, which is exponential. So now how to write it as b raised to power n multiplied by a polynomial? This is equal to 3 raised to power n multiplied by 4n raised to power 0. And you know that anything raised to power 0 is 1. So I rearranged it. So this is b raised to power n, and this is the polynomial. And the polynomial, the degree is what? Is equal to 0. So what will be the root? So the root is x minus b, and b is 3, raised to power, the polynomial is of degree 0, so raised to power 1. So the general rule here, it says that for any exponential which is constant multiplied by b raised to power n, then the root is simply x minus b, and this is the second type of function we can find its root. So if it's a constant, then the root x minus 1, and if it is exponential multiplied by a constant, it will be x minus b. So if we have 7 raised to power n, it will be x minus 7. Now the third type of functions, what if we have f of n is just simply a polynomial, let's say 3n to the power 2 plus 4. Now this polynomial does not have any exponential. So how do we write it as b raised to power n multiplied by a polynomial? In fact, this is 1 raised to power n multiplied by 3n squared by 4. So this is the polynomial, which is pn, and this part is b raised to power n. So what will be the value of b? The value of b is equal to 1. And what is the degree for this polynomial? The degree is equal to 2. So how to find the root? So the root is x minus 1 raised to power 3. So if we have a polynomial, this will be like the general rule for a polynomial of degree d, the root is, I think I need a space. Okay, the root will be x minus 1 raised to power d plus 1. So the root has x minus 1, and it's not x minus b. The last case, number 4, if we have a function that combines both exponential and, so 4 multiplied by 3 raised to power n times n squared. So this one can be written as 3 raised to power n multiplied by 4n squared. So this is the polynomial p of n, and the degree is equal to 2, and this is the equation for b raised to power n, and b is equal to 3. So the root is x minus 3 x minus 3 raised to power 3, because the polynomial is of degree 3. So we can have the general f of n equal b raised to power n times p of n. Then the root is x minus b d plus 1. D is the degree of p of n, and this is going to be the also a root if f of n is of this format. I have provided a table summarizes all types of f of n that we can find roots, and I already explained the reason why we are having those roots. So if we have a constant, the root x minus 1. If we have exponential multiplied by a constant, the root is x minus b. And if we have only polynomial, x minus 1 raised to power d plus 1. And if we have a polynomial multiplied by exponential, it will be x minus b raised to power d plus 1. Some examples to explore. Now if we have a 3 is a constant, so the root is x minus 1. Now this is only exponential, so a constant multiplied by a exponential, and here I can consider b is minus 3, so the root will be x minus b, and minus 3, so it will be x minus 3, it will be x plus 3. This recurrence relation, you can consider it consists of 3 parts: exponential, polynomial, and constant. So what you will get from the exponential, you will get x plus 3. And what you will get from 7n, it will be x minus 1 raised to power 2, because the degree of n is 1. And for the constant, you will have minus 1. Why you consider each part separately? Why you don't just consider all of it as one polynomial of degree 1? And in this case, you will have only 2 roots. So the root for 5 minus is this, and the root for this polynomial of degree 1 is this. Now here we have only a polynomial of degree 2, so the root will be x minus 1 raised to power 3. Here, this one we have a polynomial multiply exponential, so the roots for this part will be x minus 4 raised to power 3, and here we have a constant will be x minus 1. By the way, 3 raised to power n plus 1 is equal to 3 raised to power n multiplied by 3, and this is the polynomial, which is degree 1, and this is the exponential. Since this is degree 1, so we raise it to power 2, and b is a 3, so it will be x minus 3. And look at the others, and these are their examples for